Welcome to Bodhi Unified Flow. I'm Dr. Marimuthu, your host, and here we simplify complexity and amplify performance. Today, we are diving deep into an explainer all about the best practices for the design phase, specifically zeroing in on planning and pre-construction through building information modeling, or BIM. We're going to unpack exactly how you mandate BIM using ISO 1965-02 and how to establish a rock-solid BIM execution plan, defining your uses, LOD requirements, and data formats. We'll also look at leveraging BIM for multidiscipline coordination and clash detection way before you ever issue those construction documents. And to wrap it up, we'll break down implementing a common data environment for flawless version control and information sharing. The industry is rapidly moving away from messy, document-centric chaos, and this explainer is going to give you the exact data-driven blueprint to follow. Let's get into it. So here is our roadmap for today. We'll be moving through the BIM mandate, ISO 1960-50, establishing your BIM execution plan, defining the level of development, mastering interoperability and data formats, executing multidiscipline clash detection, and finally, managing it all in a common data environment. Before we start building our digital reality, here's exactly what you'll take away from today's session. By the end of this explainer, you'll be fully equipped to eliminate those historical data silos that cause massive project delays. You'll know how to optimize model maturity to stop wasting effort, and you'll understand the precise mechanics to stop multi-million-dollar on-site rework. Implementing these practices, it literally protects your project's profit margins and timeline. All right, Section 1, BIM Mandate ISO 19650, moving from fragmented silos to a singular digital vision. We're starting with this framework because, honestly, it is an absolute game changer. Implementing ISO 19650 isn't just about updating your software. It's a strategic alignment of your information management with your actual organizational goals. Historically, projects have been absolutely plagued by fragmented data silos, right? Think about how many times a lost email attachment, an outdated PDF, or a superseded drawing has led to devastatingly costly mistakes on site. One discipline simply doesn't know what the other is doing until it's entirely too late. But the ISO 19650 Level 2 mandate completely dismantles that. It ensures that we generate information once, verify it rigorously, and then use it many times, creating a perfectly cohesive project information model. Take a look at how the different parts of this standard actually work together to eliminate those silos. While Part 1 sets up your high-level strategy, Part 2 is the big one for us today. It acts as our direct roadmap during the delivery phase, the design and construction stages. It gives us the precise mechanics for model coordination. Then you've got Part 4, ensuring your systems can natively talk to each other without losing any data fidelity. And Part 5 wraps the whole thing in a rigorous, security-minded approach to protect sensitive data from cyber threats. Making sure you conform to this global standard is rapidly becoming a mandatory prerequisite to even bid on large-scale projects worldwide. Moving right along to Section 2, the BIM Execution Plan, or BEP. Establishing the digital rulebook for the delivery team. So we understand the overarching mandate. Now, how do we stop deadly information bloat and make sure everyone is playing by the same rules? You need a digital rulebook, and that's your BEP. It's your delivery team's calculated response to the client's exchange information requirements, or EIR. The EIR is essentially the granular data the client demands so they can actually operate the building decades from now. If you don't have a robust BEP answering those exact requirements, you risk generating thousands of hours of entirely useless data, or worse, leaving massive gaps that require intensive rework. Your BEP is a legally binding guide for every single subconsultant. Now, what's fascinating here is how each piece of the BEP acts as a shield for your project's budget. Take software versions, for example. By explicitly listing the exact authoring tools and their version years in the BEP, you lock the technical environment down. This completely prevents that devastating data corruption that happens when your structural guys upgrade their software mid-project, but the architects don't. Or look at naming conventions. When you have a massive federated model with thousands of elements, strict alphanumeric naming means every single file is instantly searchable. Build this into your instructions to bidders, and your trade partners are legally bound to these highly efficient workflows from day one. Let's jump into Section 3, Level of Development, articulating content reliability and model maturity. Okay, so we've got our rulebook. Next, we have to define exactly how deep and mature our models need to be at any given phase, which is where LOD comes in. Let's compare two critical stages to really illustrate this. LOD 300 gives you the precise geometry, system orientation, and sizing to generate accurate construction documentation. It's highly detailed, but LOD 400, that takes it down to the microscopic level. We are talking about modeling the exact specifications of the welds, the precise threading of nuts, and the exact placement of bolts on a steel beam required for physical fabrication. The absolute best practice here is tracking these requirements using a model element table. Why? Because it stops you from over-modeling, which wastes massive amounts of time early on and prevents under-modeling when the guys on site actually need those granular details to build the thing. Section 4. Interoperability and data formats. Establishing the universal language of OpenBIM. Think about this. If the architects are modeling in Revit, the structural engineers are in Tekla, and the mechanical team is using ArchiCAD, how on earth do they talk to each other without losing data? Enter the absolute necessity of OpenBIM. IFC is your universal translator. It's an open, neutral format that preserves geometric data across totally different software platforms, so you never get locked into just one vendor. Then there's Kobe. Look, facility managers do not want a chaotic pile of cardboard boxes full of paper manuals at handover. Kobe facilitates continuous digital information drops throughout the design phase, giving them a pristine, structured database of warranties and serial numbers. And finally, BCF. Instead of emailing messy screenshots of design issues, BCF sends a tiny file with the exact camera coordinates directly into another user's BIM software, taking them right to the problem. It's brilliant. Section 5. Multidiscipline clash detection. Resolving design conflicts before construction begins. All right, now we arrive at one of the most financially impactful benefits of BIM, catching conflicts in the digital space. We tackle errors systematically by federating our models, which basically means combining all the architectural, structural, and MEP models into one master file. Next, using specialized software, we set our tolerance limits to filter out tiny, acceptable overlaps, and we run an automated clash execution. The software flags every single point of spatial interference, and since this can literally spit out thousands of results, we use a responsibility matrix to prioritize them, avoiding total issue paralysis. Teams coordinate, fix the issues, and revalidate. And the best part? All of this happens before a single shovel hits the dirt. When we run these automated scans, we are hunting for 3 very specific culprits. A hard clash is a literal physical impossibility, like a massive steel beam punching straight through your primary HVAC duct. Then you have a soft clash. The objects might physically fit, but there's a severe functional issue, like not leaving enough clearance for a technician to safely open an equipment access door 5 years down the line. Finally, workflow clashes are sequencing issues, where trades are basically tripping over each other on site. Let me tell you, finding a hard clash digitally saves a fortune. Industry data proves that on-site rework costs 10 to 20 times more than just dragging a pipe 2 inches to the left right here on your computer screen. Finally, Section 6, the common data environment, the architecture of collaboration and version control. So you might be wondering, where does all this pristine, clash-free, highly coordinated data actually live? It lives in the CDE. And let me be unequivocally clear here. The CDE is not just a basic cloud drive or a messy shared folder. It is a strictly managed combination of enterprise technical solutions and rigorous human processes like mandatory digital sign-offs. It is the ultimate sanctuary of truth for your project. It completely strips away silos and replaces them with a governed digital workflow, guaranteeing that outdated, unverified information is never accidentally used to make a million-dollar construction decision. A file's journey through the CDE is strictly gated through 4 distinct states. First, it starts in the Work in Progress, or WIP state. This is your internal sandbox where task teams iterate freely, hidden from everyone else. Once it's internally approved, it moves to the Shared state. This is where information is passed around for multidisciplinary coordination, but, and this is absolutely crucial, it is not yet authorized for construction. Only after formal authorization by the lead appointed party does it move into the published state, becoming legally binding data ready for the site. Finally, whenever a document updates, the old version drops into the archived state. This creates a flawless historical audit trail, which is an absolute lifesaver for lessons learned or resolving any legal disputes down the line. Look at what we've covered today. We have successfully laid out the ultimate blueprint for translating planning chaos into a predictable, data-driven reality. We moved from the strategic global mandates of ISO 19650 down to the technical workflows of multidiscipline clash detection, all governed by strict CDE version control. Integrating these exact best practices will dramatically de-risk your construction phase, fiercely protect your budget, and support the entire future lifecycle of the asset. So I leave you with this final critical question to ponder. How are you going to implement this unshakable digital thread to safeguard your very next project? Here are these specific references cited in today's explainer. I heavily encourage you to explore these deeply to further simplify complexity and amplify performance within your own teams.
Thank you so much for joining me, Dr. Marimuthu, here on Bodhi Unified Flow. Until next time, keep optimizing, keep collaborating, and keep building better.